This lesson, we're going to learn how to graph the derivative of the given function on a graph. As you can see from this function fx, there are three different pieces. I color-coded into pink and black and blue. The pink line is a linear relation, the black one is a parabola, quadratic relation, and the blue one is a constant relation, which is a horizontal line. Graph the derivative of the function means graph the slope of a tangent along the curve. Let's look at the pink section first. If I pick this point and draw a tangent line, the tangent line will be exactly the same as the pink line. That means the slope of the tangent will be the slope of the pink line. If I pick this point and draw a tangent line, once again, the tangent line will be the pink line. Thus, we know it doesn't really matter where we pick on this pink line. The slope of a tangent will always be the same thing as the slope of the pink line, which is -2, except for at this connection point. At this connection point, the graph is not very smooth. It results in a corner. That means the slope of a tangent cannot be found on this point. Therefore, at x equal to 0, the differentiation, which is slope of tangent, is undefined. And when x is less than 0, the slope of a tangent is always -2. The next section we're going to look at is the blue section here. As you can see, the blue line is a horizontal line. That means the slope of tangent is always 0 along with this line, except for at the connection point. Once again, as you can see, this is a sharp corner. That means slope of tangent at this point cannot be found. Therefore, at x equals to 3, slope of a tangent is undefined, and after x equals to 3, slope of tangent is always 0. Now, let's take a look of the slope of tangent of the parabola. Whenever you see a parabola or any kind of U-shape or degree 3 functions, the first thing you want to see is where the slope of tangent becomes 0. On this graph, the slope of tangent will become 0 at the local minimum. So, at this point, slope of tangent will be 0. Next, let's pick another point on the curve. So we pick this point, x equals to 2, and let's draw a tangent line. And let's try to estimate the slope of the tangent line. So if I do a rise over run, I can see the slope is 4. So I know when x equals to 2, my slope is 4. After that, you just follow the trend of the data because I know the differentiation of the parabola will become the linear line. That means the next slope will follow the same pattern. That means go up by 4 again. And this how we go down by 4. Therefore, this is my differentiation of the parabola. And those three pieces combined together will be our f prime. Now, let's try to do this question again using algebra. So we're going to find equation of each line segment and combine them into one piecewise function. The first piece will be the pink one. So the pink one is a linear relation. So the format will be in terms of y equals mx plus b. So first thing we have to find the slope. Second thing we have to find the y-intercept. So if I look at this line, the slope is rise over run. Let's make a right triangle. You can see the rise is -2, run is +1. So the slope is -2. Next one is I have to find the y-intercept. Usually, you substitute a point that is on the line and the slope to find the b value. However, this time, we can clearly see the line intersect the y-axis at 3, so I know the y-intercept is at 3. Therefore, this relation will be y equals -2x plus 3, given that the domain is x less than 0. Next piece, which is the parabola, we can see the vertex clearly, which is at 1 and 1. So we're going to use the vertex form, which is y equals a, x minus h squared plus k, given the vertex is at 1 and 1, which is your h and k. So that's substitute into the formula. In order to find a, you have to substitute another point. So we're going to substitute 0 and 3. Into this quadratic relation to find a. And now you will see 2 equals to a. Therefore, I know the relation is 2x minus 1 squared plus 1. The domain will become 0 less equals to x less equals to 3. The third piece is the blue line there. Since it is a horizontal line, so we know the equation of the horizontal line is y equals to the y-intercept value, which is going to be 9. And domain will be x is greater than 3. Now that's combining into one piecewise function. So fx equals the first piece, negative 2x plus 3. And second piece, the parabola, 2 bracket x minus 1 squared plus 1. And the last piece, 9, x greater than 0. And then we're going to differentiate each piece. So f prime x equals, differentiation of negative 2x plus 3 will become negative 2, domain x less than 0. And differentiation of the black one, which requires the chain rule plus the constant rule, you're going to get 4 bracket x minus 1. Since the connection point, the slope of tangent is undefined, therefore the domain becomes 0 less than x less than 3. The third piece, since it's a constant, differentiation is going to be 0, the domain x greater than 0. After we have the equation of the derivative, then we just graph each piece together, and that's our derivative of the given function, f prime x.